another very important topic related with the space metrology, space technology, and the metrology, how the metrology is related with us, with it. We have with us Dr. Seni, who is from National Senior Principal Scientist, National Physical Laboratory, New Delhi, who will speak on this topic. Sir, Dikshit sir, would you like to speak 2 words?
Yes, Ashutosh ji.
Please, sir, please.
Happy Krishna Janmashtami to all. Jai. So, Lord Krishna has given some direction to us. That is work and worship. So, only the worship is not important. You have to relate with worship work also. So, work means your duties. So, you have to do your duties, and then worship will play the other important role in your life. So that's the reason everywhere the progress is there. So people are working the hard work. They are scientifically doing all the work, and they are achieving their targets day by day. In space mission, so India progress is also very high in comparison to other countries, except some countries like USA and Russia, Japan, China, etc. So you know that when the America and Rus has sent their mission to moon, so that is very long ago. I think during 60s, Armstrong landed on the moon, and that was the very big occasion. Neil Armstrong. After that, the people started to think on the theory that how the moon is like that, how people may survive on the moon. So in this way, the people started to think on the Mars also. So the Mars also has been many research work has been done here, but there is no mission like moon what has been done by Russia and America. On the sun also some work is going on, and on these three places that India progress is also very satisfied and prouding for us because we have sent the landers and all that very things, and a lot of research work is going on. So the question is that how to send it. How to send it means that you have to have that very material technology. Means the rocket what we are making, that rocket must have that very technology. You see, if you are crossing the orbit of Earth, in most of the cases, the most of the things will be burned out. So you had to cross that very boundaries. And when you are coming also, then also this is the same fundamental things are being required. So it is very tough that you get to that very technology, which is the material, which is uh, playing all the important role, that nothing will be burned and nothing will be done, so things and everything will be done. That rocket mission is very important. In the rocket mission, India has achieved a lot of things. So we have to be very grateful to ISRO. So ISRO has already played the very important role. Now we are talking on the material. on the research on the space and other type of things. One things I will also like to inform you that Elon Musk, you might be knowing. So Elon Musk is sending aircraft on Mars. And on that very aircraft, that aircraft will be in rocket mission, and that aircraft will be landed there with the full equipment. With the full equipment. And in the next time, after 10 years, those things will be available to survive the people. Then the human beings will be sent there. That how to, because you cannot just within one cell you can survive for a longer time. So you need so many items that they have done the research work out. So first they are sending all the materials for survival, and then the humans beings will go on there in the that very space aircraft, and then they will work on that very theory. So this way the mission is going on. So today topic is very interesting. I hope that all the participant will acquire very good knowledge, and we are very thankful that Dr. Praveen Shani from National Physical Laboratory has joined us today, and he will talk on this all the theories, including the material, that what kind of material this aircraft has been made, this robot has been made, and this um, rocket has been made, that they are crossing the earth and uh, very other orbit of the moon and Mars, and then these things robots has been placed there. So I speak, I request Dr. Asutosh Agarwal to request Dr. Sani to present his presentation.
Thank you,
Thank
sir.
you.
Thank you very much, sir. Thank you for your kind and motivating words. As we are all aware, the topic for today is role of metrology, advanced materials, process, and technologies for space missions. We have with us Dr. Praveen Sani, who is working as a senior principal scientist at National Physical Laboratory. He is Bachelor of Engineering in Polymer Science and Chemical Technology from DCE, now DDU, and PhD is conducting polymers from Center for Polymer Science and Engineering, IIT Delhi. He is working in this field since last many years. He has written a lot of research papers. I would like to request Dr. Sani to kindly enlighten us with his vast knowledge, vast experience, and support us in this field. Thank you very much, sir. Over to you, please.
Thank you so much, sir. Thank you for giving me this opportunity. And I must want to take slight credit that in this case, I tried my best to snatch this opportunity. I bothered you many times that I want to give this lecture because of the opportune situation that arises because of the events associated with it. So, first of all, happy Janmashtami to everyone, and happy Independence Day to all of you also. And everybody knows that independence means a kind of freedom. And the good thing is that through science and technology, we are actually achieving our real freedom in terms of the our our presence all across the world, and showing everybody that yes, we are actually free from everyone. We are interlinked, but yes, we are truly Atmanirbhar. In that sense, we are becoming free, or we are achieving our freedom. Anyways, the yours logo always say jago grahak jago, so my this talk will be an attempt to make people jago about the space, about the technology, science and technology, and everything that revolves around it. So the talk is a very simplified talk. I tried to put the things in a manner so that even the some school students or everyone who is present over there tried to make a activity with the things. I put the things in a very simplified manner and try to put the examples how there is an interlinking between the space science and technology, meteorology, various materials, other related processing technology and material fabricating fabricating tools that are available, and then ultimately what India has done in that particular direction with very small examples or very significant examples from side of CSR NPL, what we have done. And I tried to correlate with this, the bigger theme space, and generally we say that the space that is related to the outer boundary of the our atmosphere, but I always considered that space is everything that is around us. So I will touch upon bit of the things that are present on the land also, because I personally believe that yes, we can always, I mean, evolve, we can always go to the planet like Mars. Elon Musk talk about the colonization over the Mars, but we definitely should take care of our planet Earth also, because it is possible that we can, I mean, colonize over somewhere else, but until and unless we are capable enough to make our planet a better place, I mean, other things are definitely very difficult. So as I progress with my presentation, I'll try to make the things more clear. So now I'll be sharing my slides. Can I share my slides now?
Yes, please.
Is it visible to you?
Yes.
And is it in the full screen mode?
Yes, yes, very well.
Yeah, so can you see my very first slide? I am just going to very first slide. Can you see it in the full screen mode?
Hmm. Yes, yes.
Okay, just a minute.
Yes, it is the National Physical Laboratory.
Okay, okay. So you can see the main slide with the title in a screen mode.
Yes.
Okay. So now I'll be proceeding. So as I already talked about, the title of my talk is Role of Metrology, Advanced Materials, Processes and Technology for Space Missions. So when I say, it seems like there are so many keywords: metrology, advanced materials, processes, technologies, and space missions. So as I move ahead, I will try to explain them, what are these things and what is the interrelation between them in context of the space science and in general science in the space around us also. So I come from an institute called National Physical Laboratory, which is situated in the heart of the Delhi. So it's an institute of the prehistoric importance. We all know that the foundation stone was laid by late Pandit Jawaharlal Nehru and Pandit, and then later on Vallabhbhai Patel also come to, I mean, inaugurate the laboratory. So everything was set up by the big people, and it was realized at the initial stage itself, we need to have an institute which can maintain the national standards. Standards are nothing but they are a kind of benchmarks which one need to follow so as to see where we are lying with respect to that particular standard in terms of the absolute quantity or values, because quantification of things is necessary. We cannot always say that I am good, you are bad, uh, the the temperature is high or low. We need to give the values, and not only the values, the uncertainty associated with those values. So for that, the National Physical Laboratory is already present there, and CSR NPL is National Metrology Institute of India also. That means we carry out the science and technology necessary to maintain the national standards so as to disseminate and manage all those fundamental SI units and then the derived units based on the same. So as I already explained, I am working there as a scientist for last 21 years, and it happens to be today happens to be my anniversary over the NPL. So 21 years ago, today itself, I joined CSR NPL, and now I am sharing my experience and journey that I have learned throughout my career at the NPL. So let me go to the next slide. Now, can you see my next slide? I just want to confirm once.
Yes, yes, very
Yes.
well.
So the talk of the today is about the meteorology and other things related to the space science. So we all know that India has very successful Chandrayaan 3 missions in the 20 on the 23rd of August 2023. We landed near the south pole of the moon on the Shiv Shakti point at 6:04 p.m. Indian Standard Time. So when I started saying that 6:04 p.m., why not 6:04 p.m. or 6:05 p.m. and then Indian Standard Time? So that itself says that we have a certain thing for which we are actually worked very hard to realize, which plays not only the national standing across the globe, which also tells us about what exactly are our own parameters on the basis of which we have achieved this success. So when we say that the Indian Standard Time, it is nothing but it is a time that is maintained by the India through series of cesium atomic clock or bank of cesium atomic clocks, and they are actually maintained by the CSR National Physical Laboratory. So in that way, NPL is basically the agency who is maintaining the national standard time. We are the timekeeper of the India. We maintain the IST, and then we disseminate it. So we provide the time to the ISRO. So once time is there, then based on that, so many calculations are based, so many strategies are based. So that's how we are able to say that 6:04 p.m. and that exactly happened. It is not a coincidence that we started, and just like in our common conversation, we say that when you will be coming, the person say that 1 minute, 2 minutes, or 1 second, and then there is a uncertainty where exactly that person will be coming. But in the space missions and everywhere, it is not the case. So, anyways, the National Space Day was actually celebrated on the 23rd of August. That is about to come. So it is just to tell everybody about the India's huge success in the area of the space science and technology, upcoming missions, and just to commemorate the success of the Chandrayaan 3 missions. So before I proceed, there are some lines written over here. I just want to tell that I am working NPL as a scientist, but apart from that, I am a engineer by my qualification. I am a science communicator. I am very much enthusiastic about the space science and technology. I do a bit of amateur astronomy, and I am interested in the music also. So all these things are not being told to you just to boast of something that I am doing this and that. The thing is that they all are somehow related to science and technology around us, and those keeps me motivated. And hopefully once you understand the linkages between them, you also start adopting those things, so that your efficiency, your ability to absorb the things, your ability to radiate the things in a positive manner will actually evolve. So that is very much necessary. So anyways, now you should remember that National Space Day, that is NSPD, is stands for the National Space Day, that is generally celebrated on the 23rd of August, which is different from the National Science Day, NSD, that is generally celebrated on 20th of 28th of February, just to mark uh, the Raman effect discovery by the late C.V. Raman. Anyways, I just want to show you a few pictures. When you talk about the National Physical Laboratory, it is considered as the mecca of science and technology. But NPL is also a place which is beautifully green, with a lush green campus and so many beautiful fauna and flora. So it gives you additional perk. And again, this is nothing but it is a extension of the space around me, which if extended beyond the atmosphere, ultimately linked to the space. So it gives you a right kind of right kind of atmosphere, from which you not only drive so much of positivity, you can see so many natural phenomena occurring, which ultimately have the roots in science and technology, so that you can even explain your phenomena based on them. So anyways, coming back to the topic, metrology is nothing. When I was talking, it is science of the measurements. So NPL has a one vertical that works in the area of a metrology. By an act of parliament, we have to be National Metrology Institute. We have to maintain the national standard. So my colleagues and so many, fellow scientists, they are working very hard in that particular area, and many have actually spent their entire careers. And whatsoever I will be presenting, or I am talking about, that NPL has done this, NPL has provided time and other things. That is basically contributions of so many leaders, so many scientists, so many technologists that are coming from the India, that are coming from the National Physical Laboratory. So I just want to, remember all of them. I could not name them, but yes, I just want to say that because of them only the NPL, and because of them only the global standing of India is improved, because metrology is everywhere. Whether you talk about the time, whether you talk about the distance, whether you talk about the current, whether you talk about the temperature that is measured in terms of the Kelvin, whether it's a radiation intensity or the amount of substance in terms of the mole. Everything has been realized by the NPL, and based on that, the units can be derived. For example, the pressure, that is the force per unit area. So everything area means ultimately it is related to somehow the unit of depth, mass or unit of length, and then your force is somehow related to the mass or amount of the amount of the substance that is present within that, and the amount extent of the force that that material faces or experiences under the influence of the gravity. So ultimately all the things are related, so many derived units are possible. So this is the one core particular area of National Physical Laboratory. Again, if you come to the NPL, from the gate itself you see that there is a clock that is displaying the time with the 2 digits in the seconds. So those seconds are nothing but they actually give the accurate 2 digit time in the seconds of the of the Indian Standard Time. And not only we are restricted to those units of seconds, we are basically actually accurate and precise up to the nanoseconds. We have uncertainty of less than 3 nanoseconds. So that is through the series of bank of you can say that atomic clocks that is maintained by the time and frequency division of the National Physical Laboratory. They work really hard. They have created world-class infrastructure so that we are able to generate and maintain the national standard time, and we are providing that time to the agencies like ISRO for the space missions, which are very much crucial. So I don't want to say much about those things NPL is doing in the area of other aspects of metrology, as I already said, or other primary units and derived units. Just to make, I just want to, put some one-liners that are, present in this screen. You can see that just to make the science more scientific, technology more perfect, environment clean, energy sustainable, healthcare affordable, cyber security strong, trade barrier should be removed. That means it must be barrierless, and politics wise, it is a nation building. So all these things are nothing but consequences, or you can say that offshoots of the metrology that ultimately lead to the nation building. So just coming back to the first thing I was saying, whenever you see a rocket is launched into the space, so you see there is an encircled image over here, time up to several decimal points of the second. So those seconds that have been displayed, actually that time is nothing but it is coming from the CSR National Physical Laboratory. And then you can see that the Chandrayaan mission, one picture has been shown on the similar grounds only. The Chandrayaan mission 3 was also launched, where the rocket has followed the trajectory with the increasing its orbit around the earth, and then it is launched into the space towards the moon, and then again its orbit was decreased. So that was a strategy to maximize the fuel economy, though it increased the flight time over the months or even the days. But what happened, it increases the fuel efficiency, and then ultimately fuel saving, I must say. Once the fuel saving is there, the cost has been saved. So that is very much important in terms of the economical space missions which is required. So for these missions, time is provided by the NPL. And when I say that 6:04 p.m. Indian Standard Time, the Chandrayaan 3 lander will be Vikram lander will be landed. So that means how accurate and precise. You see, it's a highly dynamic system. The Earth and Moon is a two-body system. Earth is moving around the sun, then Earth is moving around its own axis, Moon is moving around its own axis and revolving around the Earth. So what is happening in this entire dynamic system? The time and other calculations are extremely important, and that's where the role of meteorology comes into the picture. It is just like, fighting another bullet which is moving in the space through another pistol. So that's a very, very accurate, a matter of very, very accurate precision, and as less as possible uncertainty. So thanks to NPL, that NPL has provided this time to nation as well as to the ISRO for achieving this landmark. So if I talk about briefly about the Chandrayaan 3 mission, everybody knows that our orbiter reached to the space around the moon on the 5th of August. And then it continues to decrease its trajectory. And once it reached to the appropriate position, it started the descent. I mean, it started the most difficult part. That means the soft landing. It seems like very easy, but the issue is that soft landing on the other, you can say that cosmological body like moon is very difficult case because of the lack of the atmosphere. So you need to have the very precise control over the speeds, positions, the way you need to fire your boosters, and the when you need to, I mean, deploy it, your other bodies which just keep it in balance, and the way you need to, I mean, switch off your boosters at the very appropriate time so that it lands very softly. So that way the meteorology plays the very crucial role. And finally, on the 23rd of August, India landed on the I mean, the surface of the moon near the at the Shiv Shakti point near the South Pole at 6:04 p.m. Indian Standard Time. So this figure 6:04 p.m. Indian Standard Time becomes a landmark because it's a success of the meteorology. It's a success of the India space mission, space science and technology. Anyways, if you see the missions, it was a, I mean, it was nothing but it was consist of a rocket with a rover and a, you can say that a orbiter module which consists of a rover, and then it also consists of a lander. So Vikram lander was present there, which consists of a rover. So once orbiter started moving around the moon, then what happened? The rover that Vikram lander detached from it. It landed over the moon, and then it deployed the ultimately deployed this Vikram lander. Ultimately deployed Gyan rover. So this was the story, but story has not ended there. What has happened? All these were carrying very important payload to carry out very important information from the moon surface. For example, the CHASTE experiment was there to just measure the thermal conductivity and temperature of the lunar surface. Then there was a ELSA activity to see the seismic activity over the moon. Then there was another probe to see the plasma and other density over the surface of the moon, and then there is a laser reflectometry array. So all these were present over the lander, that is the Vikram lander. So that once the lander landed over the moon, they become active and they started taking the measurement. But apart from that, there were some payloads on the rover also, which once came out of the lander, it started moving over the surface and it started taking the measurement. So alpha particle X-ray spectrometer apex, that has been this payload was developed by the physical research laboratory. And then there was another, I mean, payload, that is a lips. So lips measure basically the mineralogical composition. It basically measure the elements that are present. So alpha measure the mineralogical composition, but it see what are the elements present to form that kind of mineral. So these are not just the payloads. These are basically you can say that a kind of hallmark features which actually comes into the realization because of the science and technology of the nation, including the contributions from the big players like ISRO, Physical Research Laboratory. There are many other, I mean, bodies which are present. There are many other scientists and technologists from the big institutions, academic organizations that are associated for small things which are integrated to form these kinds of payloads and other kinds of systems that have been deployed. And definitely CSR NPL also played a very important role in that thing, because whenever you want to calibrate anything, NPL not only maintain the national standard, it also maintain the calibration and calibration associated with many of the equipments. And then NPL also have the reference standards. NPL know how to disseminate the national standards through various mechanisms. So NPL was involved everywhere if you talk about anything. Anyways, I mean, not only the Chandrayaan, then we have a very successful Mangalyaan mission, or that is also known as the Mars orbiter mission, because there was only orbiter involved. We have the no landing, which we'll be definitely doing in the future. So again, in that particular case, the science and technology and meteorology plays a very important role. And the again in this mission also, what has happened, the same kind of mechanism of fuel economy was, I mean, followed, in which the spacecraft basically moves around the earth, and then it gradually increases its radius, or you can say the orbit around, and then it is launched into the space. And then when it reaches the particular targeted body, it started reducing its uh, the orbit around that particular thing. So all these things have been done to just utilize the gravity of those bodies, including Earth and that intended planet, so as to reduce the fuel consumption. Though it's a time-taking affair. And the another advantage we draw from it, because of the utilization of the gravity of those bodies, less powerful rockets are required. See, we must admit that we are at the forefront of science and technology. We are not, I mean, less than anybody in the world, but we need to build our own very powerful rocket, which we were not having. Right now, we were dependent on the other bodies. But what happened with those rockets also? There is a strategy how we can achieve still the things. So that's where the India shows that okay, we will be taking the more time, but we are much more efficient than you. And with our limited resources also, we can do what nobody else has done till date. That is the landing near the Shiv Shakti point, which is a very difficult to do things, especially considering the fact that moon is a very difficult target because of the lack of the atmosphere and very difficult or very low gravity that is present over the moon. But anyways, science and technology comes to the rescue, meteorology comes to the rescue, materials were already present, processes and technology were integrated. That's how the entire game actually changes and we become the game changers. So rocket, etc. Everybody knows about the PSLV and Polar Satellite Launch Vehicle, which has been launching so many satellites also, which is carrying so many other bodies into the space. So again, it's a contribution of the India. So when we talk about the Mars orbiter, definitely it also has so many kinds of components that have been built based on the science and technology. It also has so many kinds of probes, including the alpha photometer. Then there was a Mars exotic neutral composition measurement, which measured the compositions of the Mars. Then there was a TIS, which measured the thermal profile of the Mars. Then there was a methane sensor, which measured the methane compositions. And then there is a colored camera. So that camera gives very beautiful picture of the Mars. So in that way, everything has been built. And when you see, these are not the payloads. These are basically highly interdisciplinary science and research development based ultimate outcomes, in which somewhere the sensor is present, somewhere the a high-end electronics is present, somewhere the AI or data science is involved, somewhere the different, you can say that the detectors are present. So in that way, some different materials, those things have been made out of different materials, and just to process those materials, different technologies are involved. So that way, it is ultimately reflection of what a very highly skilled interdisciplinary target-oriented team can do. Anyways, I mean, when we talk about all these things, India's missions and everything, I just want to tell that we always aspire that okay, someday there is a problem at the atmosphere of the earth, there is a pollution issues and this and that. So as per saying of the Elon Musk, probably we may be colonizing on the Mars someday, but we should remember that space is also not free from junk and pollution. So we have to be very much careful. If we do not know how to manage our things, it will be very difficult case. So next slide showed something about the e-waste in space. So if you see, it's from the 1957 to 2005 and then to 2030, the dots represent the space junk that is present, which is due to either the decommissioned satellite, or maybe a fragmented portion of the a body that has been launched into the space, any other kind of stuff that is being generated as a offshoot of any kind of mission. So they are basically present within the space. They are orbiting around the earth in a different distance from the earth, in a different orbits. But yes, our science and technology is still capable enough, though they are present. And it looks like the if you see the last picture in 2030, it looks like there are so many bodies how our aircraft will pass to the moon or any other body. So thanks to the science and technology, we know, we track each and every object, we know where exactly is their position, the distance between them, so that we can easily, I mean, move between them. And just want to tell that it is a very huge amount of junk. Still they are very far distance space apart. So right now it is not a problem, but yes, management of that junk is required. So space junk management is again a big challenge. And for not only India, all the bodies, including the NASA, is just looking into it, how to manage this space junk. I mean, it is not easy to, I mean, take them back to the earth and do something. It is also not easy to, I mean, just burn them, just make them come to the earth, and that while doing the re-entry into the space, it burn it out, because making them to come back to the earth also requires some effort. That is a very costly mission, so that is not so much easy. So can we have something, we can we design some kind of things so that all these junks can also be managed? That would be great addition. And as you know, that this picture also shows that International Space Station, everybody knows about ISS, and our very successful mission in which the respected Shubhanshu Shukla ji went to the Indians, that International Space Station, and come back. So India also have its own mission, so that it will be launching its own, space station in the future. But for that, definitely will be requiring so much of efforts, for which much more advanced science and technology, much more evolved metrology, much more evolved materials, technologies, and the way how the same thing can be integrated to realize those targets is required. Our Chandrayaan 3 lander and the rover, they could not bear the very low temperature that actually happened over the surface of the moons when the sun set. But in the future, we will be equipped enough to make kind of probes which not only, survive those conditions, they will bring back the samples also, and someday we'll be going back to the moon. And just to tell you, moon is a very nearby object in terms of the vast expanse of the universe. It is only 1.3 light seconds away from us. Only 1.3 light seconds. So you can see that such a small, small target, and still, we need to do so much. So what is the kind of efforts required if we want to, land over the Mars, or maybe if we cross the boundaries of the our solar system? So, anyways, waste management is a very serious issue, not only in the our planet itself, but in the extra planets space also. In the space itself, it is a very important challenge in the system, like highly equipped system like International Space Station. So everything has to be maintained in a closed system. So it may looks like that bit dirty also. It may looks like big. You might be feeling that it is not that much pleasant, but there you need to recirculate the water also, including the sweat and urine, and the water that is coming as a outlet of that recirculation is much more pure than any of the water sources present over the surface of the earth. So that is the science and technology capability that we, as a people of the science and technology community, are building up through the interdisciplinary challenges. And again, the waste management. See, that's a very strange challenge, but NASA has thrown open this challenge, the space poop challenge. You need to manage the excreta and other things over the space. So that is required. So that the kind of challenges we people are facing while doing the things. So that is many things in context of the space. So now, as I said that I get involved in science and technology in terms of the space, what I am doing in my lab, I'll be definitely explaining you. But I am also a astronomy enthusiast, so I thought it is right platform to show you some of the things. So on the left side, there is a picture that has been taken by me through my telescope, which is the conjunction of the Jupiter and Saturn. It happens in the December 2020 at the COVID time. So I could find some time where you can see that Jupiter at the top with all its four Jovian moons. That is Io, Europa, Ganymede, and Callisto. And then there is a Saturn. So this is the direct picture. If you zoom in, you could see the rings of the Saturn also, and beautiful band of the Jupiter also. But because it was conjunction, so it is a low resolution image. And on the right side, I think on the August 28th, I have taken another picture in which you can see the surface of the moon, in which you can see the golden header also. It's a very beautiful picture over the surface of the moon, and you can see the other craters, etc. So why these things are possible? These things is not only possible because I can purchase a very good telescopes and other things, because those telescopes and now started being cheap telescopes has started coming in the India itself through the various private bodies. They started making those kinds of things. But yes, when we talk about the space telescopes, just like the James Webb Space Telescopes, or maybe the Chandra Space Observatory, or maybe the your Hubble Space Telescopes, or any other kind of telescope that are present over the Earth, high-end telescopes still has to be materialized by the Indian science and technologies, which again not only required the knowledge of the optics, material science, coatings, different electronics, the ability to manipulate it in a such manner so that it can track the bodies, etc., is required. So much scope is there, right from the Earth to the space. So boundaries are very vast. Again, this is picture through my telescope. But anyways, I mean, now coming back to the real topic, I just want to say that because we are talking about the meteorology, so I just want to point that World Meteorology is always celebrated on the May. So what happens on the 20th of May? Every year it was celebrated. Last year the theme was "We measure today for sustainable tomorrow," and this year the theme was "Measurements for all time for all people." So you can see that meteorology and somewhere sustainability, when we talk about our concerns about the environment, comes into the picture. So both these things are definitely interlinked, and that's where we should all be very much careful while doing anything. We should see what happened to the material at end of its life. So again, the World Meteorological Day is celebrated everywhere. Meteorological Day means the science of the weather. So it is celebrated on the again it is celebrated on the March, but the theme every time again started, I mean, relating to the more and more towards the science and technology, which talks about the atmosphere, weather, our environment. So concerns are starting becoming very much in that particular area. World Environment Day, if you talk about, in the 2018 the theme was beat the plastic pollution. 2025 again the theme was beat the plastic pollution. So we are celebrating all these days so as to make everybody aware that what are the challenges, and then we are again, I mean, trying to do holistic approaches and efforts in that particular direction so that those targets can be met. But yes, in 2025 we again come back to same target. That means we have achieved a lot, but still a lot to go. So how that things can happen? It is not only the science and technology that is going to play the role. It our general public and people who need to become the a kind of volunteer people or volunteers for different activities. They can become the you can say that non-official scientists and technologists also through various kinds of missions. Every scientific organization now launching the outreach activities also, training programs also. So through that, the different peoples and different entities present over in our society can also get interlinked with these kinds of things. Anyways, I mean, as I was talking about the space concerns and other things, global warming is a big issue on the Earth, and it is because of the pollutions and different kinds of scenario that is being generated. And these kinds of problems are already persistent on the different planets which do not have the habitable conditions at just like the Earth. So they may be free from the dust and other kind of pollution. They may be free from the noise pollution, but yes, they do not have the right kind of gaseous atmosphere. They may be rich in methane, carbon dioxide, other kinds of gases. So when those kinds of atmosphere or those kinds of gases started dominating the Earth atmosphere, again our planet started become more less inhabitable, and the situations become critical. So that's why we should be very much open eyed about what exactly is happening around us. We should control our action. We should not always blame the government, scientists, or this and that, that because of them this is happening, because of them there are dust problems, there are pollution, this and that. In most of the problem we are also, I mean, linked somewhere, so we need to understand that link and we try to play our part. Definitely things will improve by leaps and bounds. So anyways, as I was talking about the science and technology space, so I just want to highlight two of the NPL's biggest contribution in that particular area. Definitely NPL is doing high-end metrology. So all the SI units and the related parameters, they have been translated to different agencies. So I need not to say that while making some technology, while measuring something, while modifying something based on the feedback, definitely you need the quantification. So quantification is only possible when you have a accurate and precise measurement. So whether you talk about the medicine, space, any other high-tech area, NPL is always there in terms of its metrology. NPL provides time traceability to the nation. It provides the time traceability to the ISRO. Because of that successful rocket missions are possible. Apart from that, NPL provides, and it works in the area of a very high-end materials known as the advanced material. So one such material is carbon-based materials. So carbon material had different properties, I mean, which are required, including the very high, you can say that the strength, very high thermal resistance, very high thermal conductivity. It is corrosion free and it is very lightweight compared to the different kinds of metals. So what happened? NPL initially designed one carbon-based carbon-carbon rings for the polio patients, and then NPL in the same time, in the same era, NPL also prepared the carbon-carbon composite-based rocket nose strips, which are very much essential for to ensure the safe re-entry of the vehicle. Everybody knows that what happened to the vehicle discovery, that when it was making re-entry into the Earth space carrying the Kalpana Chawla and other. So that was a very unfortunate incident. But the reason may be different. But the thing is that the nose strip is a very important element that only maintain that not only maintain the aerodynamics or the air friction resistant drag, but it also dissipate the heat and manage the heat. So NPL has designed that thing. That is another material science related contribution from NPL side. So that way NPL is providing its roles. And there are other ways also. And as I said, NPL is developing other technologies which may be integrated into the different missions. For example, the corrosion resistant coatings, some CSR LEMI, other CSR LEMI providing the different kinds of ceramic and tile based on the same. So all other labs are there. So they have their different roles that need to be played, and they are doing their part. So I'm coming back to the Earth. I just want to take you back to the Earth and talk about the space around us. Definitely, we have the pollution problem. These are the common figures. And what are the solution? Uh, whether you go to the outside space or you are present on the space around us on the Earth, we need to manage our resources. We need to economize our consumption. Responsible consumption is very much important these days, and responsible disposal. They are the keys. And just to manage those things, reduce, reuse, and recycle are the strategies. First of all, we should segregate our waste. We should not create the complicated waste, whether it is considered on the life on the earth or our situations around us, or whether we are talking about the space. And then we need to talk about the circular economy. Circular economy and circular approach is already taking place on the ISS also. I talked about the water circulation and other resources circulation over there. Similarly, same kind of things should happen over the planet, so that we, after taking resources from the earth, making something, we should not worry about the disposal and then ended up pollution. We should try to reuse the things while extracting maximum out of it, and disposing of minimum amount of things. Again, I am giving you very small examples, and I'll be explaining at the last why I'll be making these examples, what they have the relation with the space, science, technology, and meteorology. So I'll try to make a statement at the end. So everybody knows that the tea waste. So our institute also, we generate the tea waste. So it can be used for making the compost and other things, very small activity. It can be used for making the high-end products like activated carbon, just to demonstrate it for the supercapacitor application. So when I am scientist, I will be looking from the scientific solutions. When you are a common public, try to look from the common solution, so as to make sure that less amount of complicated, that is mixed waste, can be generated. Organic waste may be managed at the source itself. So that is the takeaway message from this slide. And then, I mean, people like us, we are working on the different technologies. One of them is the corrosion technology, in which even the scratch site corrosion, if there is a scratch or pinhole, no corrosion takes place because of advanced material like conjugated polymer we are designing. So probably they may be this kind of technology are having the great implications in space science and technology. Definitely in the space science and technology, another aspect, that is the radiation resistance and the resistant to the cold and adverse climate conditions, or I should not call the climate, the space conditions, very harsh space condition, low and extreme temperatures, radiations, and other things that have to be encountered. But these solutions are giving very good response to us. So again, we know the technology, how to manage the waste present all over the earth. For example, is it the common agricultural waste, or whether it's a common disposable waste that is being generated nowadays while during any kind of ceremony or any occasion that is happening. We have a very big conference on the sustainability, but at the end we leave a very, I mean, bad situation with so much disposable waste. So we should take the responsibility of that kinds of things. Now we have the capability, so only reason of showing them that now we have the capability, I can make a case to you and I can make a folded hand request to all of you, please manage your waste, try to find out the solution so that the littering should not happen at all at the first place itself. If if those kinds of solutions are required, I mean they can always be provided, but most importantly, try to minimize your carbon footprint, try to minimize the waste generation itself at the first place. And there is no harm if you someday you will be carrying your own glass of the stainless steel, or you may be carrying your own thali at the conference or somewhere else. How does it matter? I mean, if one started doing something, other people also starting following. And I don't think every time our prime minister or any other big leader has to come to the TV and say about something, then only we start implementing. We should, just prove our self-conscious. We should ignite that spark and we start taking the responsibility. Anyways, I mean, we have at the NPL took that responsibility, not only developed the simple technologies, we developed the technology for plastic waste, the paper try technology, for the complicated waste, for example, the medicinal blisters, for which no effective technology is available. Only technology is available, which is a very high-end technology that requires a very high investment, cryogenic waste technology, cryogrinding waste technology. So not our small scale or medium scale industries cannot manage those things. Until unless we have that kind of solution, nothing happens. Similarly, your multi-layered plastics, biscuit, chocolate, other kinds of wrappers, which are littered here and there. Until and unless we have the technology, who is going to pick up those kinds of waste? They will more interested in picking up a Coke bottle or a Pepsi bottle or a mineral water bottle, empty bottle, because the technology is developed for those things. So we are working on these aspects also. We know how to manage the PCB waste. We know how to manage the end of life lithium-ion batteries. So ultimately, we know how to manage all these kinds of waste, and technologies are present with us. Whether they will go to the space science and technology, whether they will go to the other societal areas, ultimately is a game of the collaboration and a, you can say that, a ecosystem that we people are forming. And I know that today also there are some people who are expert of some particular area. They may be a subject matter expert of the very small content that have been shown by me, a very small subset of that particular broad area that I have shown. They may be the expert, there may be the students also who knows a little bit about the things. So when I talked about all these things in a bit mixed manner, the only way of telling those things is that we should understand what is happening around us, what are the different areas, what is the interrelation between them, and what is the still unexplored possible relation between them, and how it can be used to the advantage of all of us, to the society, to the mankind, and to our universe also. So there again the role of everybody comes. Always talk about the sustainability grid. I know that industries are doing their part, government is doing their part, NGOs, experts, investors, entrepreneurs, influencers, innovators are present. So what will happen, all of them are doing something. Definitely, that's why not only the standing of our country is improving, we are also getting, I mean, we are also getting the kind of benefits, a kind of you can say that, the the kind of right kind of atmosphere, right kind of facilities, right kind of infrastructure we are getting because of all these people. But we never realize that somewhere the general public and people like us, see, I am also a scientist, but when I come out of the office, though I am a 24 hours employee, but I am a common public also, so I become a part of the common public. So there also I should keep my eyes open what exactly happening around me, where there is a societal dust problem, whether there is a littering problem, where there is another problem. So can I solve that problem through my science and technology? Can I solve that problem as an individual? And what manner and what are the resources required? So I should somehow find my way to fit into that sustainability grid. Then only best solution will come, and everybody can find the solutions. Once you start seeing the problems, then only the solution will come. Otherwise, if you remain ignorant and start blaming, this government is not doing anything, previous government was bad, this minister is good or bad, this is the problem. Okay, we can always talk about the situations, but please realize that somewhere we also have our responsibility, and that's where everybody has to work in synchronization. So anyways, I mean, before I move out of this grid, just to see, or just to make other people realize that whosoever are not from the scientific fraternity or the common students, they are also very much important. They are equally important in this presentation or this seminar. So I just want to remind them that their role is also important. So please be there and try to listen and absorb the things we are talking about. Anyways, we also know that the solar panels, they have always been deployed not only in the spacecraft, but they are present everywhere on the earth. So who will manage the waste of those solar panels? Definitely we have to manage, and then we have the technology for the solar panels also. We know how to, I mean, remove the dust problem associated with solar panel through the waste itself. We derive the waste, we convert that waste into useful nanoparticles, and through nanoparticle we could able to make certain composition which, when coated over the solar panels, lead to the cleaning of the solar panels. See, you can see on the top left, on the top right side, there is a image. On the half part there is a uncoated solar panel, and the right part there is a coated solar panel with our coating. And on the left part you can see that uncoated part remains, water remains stay over the surface because of the hydrophilicity of the glass or silica. On the right side it immediately roll down, taking away the dust. So we know how to do it here. Probably in the space also, it altogether different versions of technologies are required. Not space, we do not have the dust, but we have the other kinds of challenges. So there the similar kinds of coatings may be used to protect the corrosion of the material, and that corrosion generally happens while the transportation of that particular thing or device into the space through the our atmosphere. So at that time probably some solutions may evolve. So anyways, the nutshell I just wanted to share that we need to change our mindset everywhere, not only in the context of the space and technology, but we can do how, where I fit in the sustainability grid. And when I become a common man, if I see the various problems around us, for example, the waste problem, so I need to realize what I am and what I am blaming somebody else. What is the problem? Who is the problem creator? Who is the problem solver? And what excuses I am taking sometimes to get away with the things or situation around us, because I am not doing anything about that thing. So I need to take the responsibility. I need to realize who I am. Then only the things will improve. And it is not only responsibility of any one particular person, it is responsibility of entire community, entire city, entire nation, to work in a coherent manner to resolve all these problems which are otherwise making our beautiful planet a bit inhabitable. Anyways, these are some pictures. When I say something that I am doing this and that, I always show some pictures. So these are the pictures what we are doing, right from the composting to management of the waste to containment of the waste, so that I can process it within my own home. Or whether the composted material out of the waste, a compost has been prepared, application of same in my own garden, and the produce coming out from therein. Or involvement of me in the community exercises when I am not actually involved as a scientist. So what I am doing, I'll be managing the localities or parks around me. I'll be building the spaces. I'll be building the things, so that people started making connectivity with the science and technology. I cannot immediately go and started talking about the rocket science. I may start talking about the waste, then recycling of the materials. So the tiles that have been you can see in these structures, they are just made from the waste tile technology made by the NPL. So I made a composting zone. Then I started tell them how easy is the composting, but how messy we people are. Sometimes we make up the rotting of the material rather than the composting. So instead of getting the very beautiful smell, we get the foul smell, and then we scared away from the composting. That's why we are not doing anything. So everywhere our role is present, we need to, again, a disposable related problems. A big event happens, littering everywhere. Bhandara happens, littering everywhere. So we are worried about our God, our most whosoever deity we are following. But we should all remember that the most highest form of the God is nothing but our mother nature and its beautiful creation. So we should take care of them, and devotion of them is the taking care of them is the highest form of devotion or adoration, I always say. So we always, I mean, involve the students so that they also understand the problems and come out with something. We involve the community workers, we involve the safai walas or other staff members. And once we, I mean, just play our part, apart from working as a scientist over the certain events as a common person, you can see the situation of the place 15 minutes after the event, which otherwise took few days. So we have our responsibility, we should keep our eyes open. I know that when I'm talking about space to these kinds of applications, Again, you may be drifting, you may be realizing that I am drifting from here to here, but my main bigger aim through this seminar was to awake your consciousness, just to make you more aware about what are the possibilities around us, see where are the general responsibilities, where the science and technological solution may be possible, how this technological solution can resolve not only these problems but the bigger problems for the nation building, and then how ultimately we can contribute towards our space missions or other kinds of technologies. Anyways, these are the few school students who visited the NPL and done something in that particular direction. I don't want to spend again much time. This is our team. So myself and few students, and they have taken the different kinds of problems so as to resolve the societal issues, not only coming out with some publication, submitting some thesis, and ultimately getting away and then moving for the job. So they ultimately converted into a characters with a inclination towards solving the societal issues. So that's what I always tried, and I challenge those people. And if you talk to my student, definitely they will talk like any other, student, that our guide seems to be a very motivating person, but when it comes to the work, he sometimes is not helpful. He just leave us to do something independently. So that is actually required. Then only they will become their own identity rather than becoming my own clone. I don't want to produce the clones. I want to produce the better persons, much better than me. And I am proud to say that all of them better than me in terms of their outcomes and in their thought process and their will to do something for the society. So that is what I wanted to tell you about the space, our atmosphere. Space is a general term. I again say that I am using the space as a general term to take advantage of making connectivity with all of you in broader context. So that's what I wanted to say. So let us make amend for our past, act responsibly and revive the nature. That means whatsoever has happened in the past भूल जाते हैं उसको. अभी हम सोचते हैं कि हमें क्या करना है कि आगे कैसे अच्छा हो, हमारे नेचर को, हमारे प्लेनेट अर्थ को इंप्रूव करना, और जब हम दूसरे प्लेनेट्स पे जा रहे हैं तो यहाँ से और इक्विप होके जाना और वहां पे अच्छा काम करके दिखाना, और दिखाना वर्ल्ड को कि हम जो है बाकी सिविलाइजेशंस को दिखाना कि अर्थ पे जो सिविलाइजेशन है वो ना केवल वेल डेवलप्ड है, वो एक्चुअली में होमो सेपियंस है, वो इंटेलेक्चुअल्स है जिनको कि ये भी पता है कि व्हाट आर डूज एंड डोंट्स. जब हम इंडिया से यही काम करें तो हम वर्ल्ड को दिखा दें कि इंडिया वाकई में ही जो है अभी आज की डेट में पूरा आत्मनिर्भर हो गया है. वी आर आत्मनिर्भर इन ऑल सेंस, एंड वी आर ऑल्सो नॉट ओनली सेल्फ रिलायंट, वी आर द एक्चुअली विश्व गुरु एंड वर्ल्ड लीडर्स. तो उसके लिए सबका कॉन्ट्रीब्यूशन बहुत जरूरी होगा. और मैं आपको लास्ट स्लाइड में जब ये कहना चाहता हूँ कि ये मिल्की वे गैलेक्सी है जिसमें हम रहते हैं, ये बिलियंस ऑफ गैलेक्सी का एक छोटा सा पार्ट है. और जो आप येलो सा सर्कल यहाँ पे देख रहे हो ये हमारा सोलर सिस्टम है. तो मिल्की वे में आपको कम से कम 1 लाख साल लगते हैं अगर आप इसको क्रॉस करोगे, 1 मिलियन ईयर्स if you travel at the speed of light. So we are a very small part of this universe. Even solar system is small part, and we are a very small part of that solar system. So please understand that we are blessed enough that even in this universe we have a special standing, we have a habitable planet, beautiful planet, we have the very beautiful and intellectual people around us. So let's make very important realization that we have been sent here with a bigger purpose. So try to resolve whatsoever conflicts we are having, try to understand that bigger purpose, try to become a good individual, try to become a good scientist technology, try to find where we fit into the bigger picture, what are the our roles and where we can contribute in the sustainability grid. And I am sure you will be definitely contributing towards the future missions of India in all the arenas, including the space missions. And the days are not far away when we will be landing, when we will be landing on the moons, when we're landing on the Mars or maybe the other planets with the manned missions also. So that's what I wanted to tell you, and I think that is all from my side. I hope you liked the presentation. Thank you. Thanks a
Thank
lot.
you.
If
Thank
you
you very
if
much,
you
sir.
have any concern or
Thank you.
any questions, please feel free to ask. And if I bored you anyway, I drifted you anywhere, I made a random kind of presentation, I can always feel apologetic to everyone. But I think I'll be able to maintain the connectivity. That is more important. Silent references have been sent into your mind, and I hope it will make you a real responsible citizen, and I will be able to deliver the function of not only the Jago Grahak Jago, but Jago Hindustani or Jago Indians or Jago Dunia Walo Jago. Thank you. Thanks a lot.
Thank you very much. I would like to thank all the participants, expert Dikshit sir, for making this today successful. Thank you all. Atulji, can we take few photographs?
Yes, sir.
For the social media platform?
Yes, sir. Can we close?